Hey, what's up, Trekkies? Today, we're going to finish our unit, and we're going to talk about 3 more types of graphs. We're going to talk about square roots, cube roots, and cubics. So square roots you've already heard of, right? Square roots. Cube roots are just another type of root, but instead of asking ourselves what number times itself is 100, of which the answer is 10, we're asking what number times itself 3 times is a number. So we put a little 3 on the root. One example of that would be cube root of 27. 3 times 3 times 3 is 27. So the cube root of 27 would be 3. Okay, so it's just going backwards. Then cubics are if we have x cubed. So we're going to focus on those 3 types of functions today. We're going to go over transformations. They're super similar to what we talked about in the last video. Then we're going to look at some parent functions and some graphs, and then maybe work backwards where you already have the graph and you need to find the equation. So let's go look at some parent functions first. Okay, so don't look at the graphs yet. Let's remind ourselves how transformations work. We're going to have f of x equals a times x minus h in some kind of function, right? These parentheses could be a lot of different things. They could be a square root, that's totally okay. They could be a squared, that's fine. They could be an absolute value. It really doesn't matter what the function here is. It just matters that you have an x with an h inside with it. That's the pattern you want to look for. Don't worry too much about what the equation happening to that x minus h is. Plus k. So remember, a can stretch stuff, but more importantly, if we have a negative a, that's going to flip the graph. That's the one that we're really going to worry about today. H is our horizontal shift. And remember, the sign is reversed. So if we have like, let's say x minus 2, even though the negative side of the x-axis is to the left, we're going to go to the right because we do the opposite of what the sign says. Then k is our vertical shift, and the sign will match. So if it's a plus 3, we're going up 3. A, h, and k are going to be in common for all of these types of functions. So if we see a, h, and k, we don't have to worry about them doing something different for that function. They're going to do exactly the same thing. So that's why we study parent functions and transformations, is so that we can find patterns in these things to make them a little more accessible and easy to manage. So we've already talked about quadratics and absolute values. Let's take a quick peek at these. We're not going to worry too much about how to graph them. We'll give you the gist of it, and then we'll use transformations to get any new graphs. So let's start with a square root. The parent function is f of x equals the square root of x. So if we pick some x values, let's pick poorly first. Don't write this down, okay? Put your pencil down, hang out, chill out for a sec. I'm going to do this a really dumb way first. Let's pick -2, -1, 0, 1, 2. Okay. We need to remember, first of all, that you are not allowed to take the square root of a negative number. This is illegal. You can't do that. So if I use -2, I have f of -2 equals the square root of -2. You can't even do that. You don't get real numbers. So this one, there's not an answer. There is an answer that we'll learn about later, but for right now, there's not an answer. Same thing with -1. All right, let's try 0. F of 0 equals the square root of 0. We're asking ourselves what number times itself is 0. That's the question this is asking. So if you have 1 times 1, that's 1. If you have 2 times 2, that's 2. So what number times itself would be 0? 0, right? 0 times 0 is 0. Okay, so the square root of 0 is 0. The square root of 1 is, well, what number times itself is 1? 1. All right. Now, what number times itself is 2? Don't say 1, because 1 times 1 is 1, right? And don't say 2, because 2 times 2 is 4. The answer to what's the square root of 2 is 1.414 dot dot dot. And this thing goes on forever randomly. It's an irrational number. So that's an ugly number, right? We're not going to want to do that. So let's go back and try this one more time. If we want f of x equals the square root of x, let's pick x's that are easy to plug in. You can write this down. Okay, well, we know the square root of 0 is 0. Okay, square root of 1 is 1. 2 doesn't work. 3 doesn't work. How about 4? Do we know the square root of 4? Yeah, it's 2. What's the next perfect square number? So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 would be 9. So 9 is the next number that's going to be easy for us to plug in. So this is going to be 3. And then you want all your perfect squares over here. And then the y's are the number that you squared to get these. So you'd have 16 and 4, 25 and 5, 36 and 6, and so on. Okay? So for our square root, it starts at 0, 0 because of our ordered pairs. 0, 0. Then we have 1, 1. Then we have 4, 2. Okay? And then it goes on with the perfect squares. This one right here would be 9, 0. Or sorry, 9, 3, pardon me. Okay. So that's square roots. All right. Let's talk about cubics, and then we'll see why cube roots are a little bit different than square roots. Notice how square roots just stop at 0, 0, and cube roots don't. That's because you can take cube roots of negative numbers, and we'll see why in a second for cubics. So for cubics, let's pick some numbers to plug in here. So x, y. Now we'll use -2, -1, 0, 1, 2. And I'll throw a 3 on there just in case. So we're doing f of x equals x cubed. So this means this number times itself 3 times. So 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. And then 3 times 3 times 3 is 27. So you can see that these numbers start to get really big really fast. Okay. What about -1? -1 times -1 times -1. -1 times -1 is 1 times another -1 turns it back into a negative. So we get -1. Isn't that weird? So when we do squareds, -1 squared is +1, and it changes to positive. That's because if you have an even number of numbers, the negatives are going to cancel each other out. If you have an odd number, like 3, then you're always going to have one left over that changes it back to being negative. Last one, -2 times -2 times -2. Negative times negative is +4 times -2 would be -8. So we can see we're getting the same number as when we plug in the positive one, but you get a negative answer when you plug in negatives. So if we put -3 on there, it would be -27. Okay, so there's our parent function. You might want to either write this down or remember it. You're going to have a graphing calculator handy, so I'm not sure how important it's going to be to you, but it's worth memorizing if you're going to, take another math class someday. Let's talk about the cube root. I'm gonna show you one example, and then I'll kind of hand wave the rest of it. So let's look at f of x equals the cube root of x, and we'll plug some numbers in. Let's do negative 8, negative 1, 0, 1, 8. So just like for the square root, I picked perfect squares for the x's, 0, 1, 4, 9. For the x's of a cube root, I'm going to pick the perfect cubes. So 0, 1, 8, 27 if you want. Okay. For the y's, we're going to just take the cube root. The cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8 is 2. And the cube root of 27 is 3. Notice how these are inverses of this. All I'm doing is taking the cubed parent function, ordered pairs, and reversing the order. So we had 327, now we have 27,3. We had 2,8, now we have 8,2. Okay. So the same thing will work for the negatives. So we're going to have negative 1, negative 1, negative 8, negative 2. Let's just double check that this checks out. The cube root of negative 8. So we're asking what number times itself 3 times is negative 8. So negative 2 times negative 2 times negative 2 is negative 8. So we can go backwards and say, well, the cube root of negative 8 must be negative 2. This checks out. If you try and ask yourself, what number times itself is negative 9? Well, it's not 3, right? Because 3 times 3 is positive 9, not negative 9. It can't be negative 3, because negative 3 times negative 3 also equals 9. And it has to be times itself, so you can't mix and match negative 3 times 3, because now these aren't the same number, so it's not times itself anymore. So you can't take even roots of negative numbers, but you can take odd roots of negative numbers, because you'll always have one leftover negative to turn it negative. Okay? So our cube root function is just the inverse of the cubics. And we learned about inverses in our last unit. Okay, so there's how we get these graphs. We're going to worry about the transformations now. Okay, so let's go describe some transformations. We want to describe the transformations from f of x to g of x. So how did I get from here to here? Well, we have a plus 4 for h. So we know that that's going to shift left 4. And we have a minus 7 for k. So that's going to shift down 7. Okay. It doesn't matter that this is a cube now instead of a squared. It doesn't matter that it's not an absolute value. A, h, and k do exactly the same thing for every single parent function. Okay. Even ones we're not going to talk about. If you had f of x equaled negative sine of x minus 2 plus 3, it still gets flipped, it still goes right 2, and it still goes up 3, even though you have no idea what that sine function does. Okay. So you're just looking for a, h, and k, and then you'll describe the transformations. Let's look at this cube root one. Well, now we have a negative in front. So that means our a has changed sign, so it's going to flip. So we're going to say reflect vertically. And this is inside this function with the x. So this minus 6 is an h value. Normally negative 6, negative would be left, but remember h is reversed. So we're going to go right 6. And we should probably say shift. So there's our transformations. They work exactly like they did yesterday. All right, now we're going to write some equations. So first thing we want to do is read this, set up our parent function, and then we'll identify the transformation. So we want a square root function. So we're going to have f of x equals, leave a little room for a, the square root of x, and we'll leave some room for k, for h here. All right, translated up 7 up and down is k. So we're going to put a plus 7 on the outside of the function. And right 6. This is an h value. Right is normally positive, so we need to change the sign for h. So we're going to put minus 6 inside. And then this would be our equation. All right. A quadratic function, so f of x equals, remember the word quadratic means x squared. So we're going to put some parentheses, put an x on the inside, and put a squared on it. Translated down 1. This is a k value because up and down is k. So we're going to put a minus 1 at the end. And reflected across the x-axis. That's another way to say flipped or reflected vertically. This is an a value, so we need to make our a negative a. So we're going to put a negative sign out front. If you don't like this big blank space for h, you could rewrite it as negative x squared minus 1. Cool. Last one. We want to write a cubic function, so we're going to put f of x equals cubic, means x cubed, right? You can see the word cube in there, sort of. So we're going to have parentheses, just like we did up there. Put a 3 on it for cubed, because cubes are 3-dimensional. Translated up to, that's a k value, so we'll put plus 2 for k. Left 8, that's an h value. Normally left is negative, so we're going to flip that sign and put plus 8 and reflected. So that's a turning into a negative a. So we're going to put a negative sign in front, and this is the equation of that function. Not too bad, right? So you just set up the function, identify what variable is in charge of the transformation, and then put it into the function. Okay. Now we're going to do some graphing. So we want to graph the function and identify a, h, and k. So let's go ahead and put a, h, and k. A, h, k. I'm also going to put the vertex here. All right. So let me graph the parent function first. The parent function would be if we didn't have h and we didn't have k in there. So it'd just be the square root of x. Let me give you the x's and y's one more time. So x, y. If I want to do square root, we want to pick numbers that are easy to do the square root of. So we're going to pick perfect squares again. So the perfect squares are 0, 1, 4, 9. And then y is just what happens when you take the square root of that x value. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. Square root of 9 is 3. So here's our parent function, and I'll graph that in blue. So we have 0, 0, 1, 1, 1, 2, 3, 4, 2, and then 9, 3. There's our parent function, square root. All right, now let's go look at the transformed f of x function. And we need to identify a, h, and k. So a, there's nothing here, so it's just a 1. H is this number in here, but we need to change the sign. So it's at 3. K is this number at the end, keep the sign. And our vertex is still at hk, so it's going to be at 3, 1. So we're going to go 1, 2, 3, 1. That's the new vertex. Let's talk about the transformations. This h is going to move to the right 3 and up 1 because of the k. So if we take our original vertex and go 1, 2, 3, 1, we can see it lands on the new vertex. So now we can just take all of our old points and transform them. 1, 2, 3, 1. 1, 2, 3, 1. And then this one's not going to land anywhere nice. 1, 2, 3, 1, about. So there's our new function. Not too bad. So graph the parent function, then you can transform it because we know these transformations, and you can just count left and up. All right, let's look at this cubic function. So we're going to get A, H, and K. We're going to get our vertex. But first, let's go ahead and look at the parent function, which is f of x equals x cubed. So it's easy to cube numbers. We can pick any numbers we want. So let's pick ones that are going to be easy. So let's pick -2, -1, 0, 1, 2. 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. -1 times -1 times -1, so cubing it, would be -1. And then remember, the negative x's are the same as the positive x outputs, just with a negative sign. So this one will be -8, because they should match up. All right, so here's our parent function. Let's go graph that so we can see what it looks like. So we have 0, 0, 1, 1, 2, 8, 1, 2, 3, 4, 5, 6, 7, 8. And then -1, -1, and then -2, -8. So here's our parent function. Just gonna look something like that. Yeah, I missed a little. Let me try that one more time. Let's start from the top and see if I can get a little better that way. Much better. Okay. So there's our parent function. Now we'll go find A, H, and K, and then we'll do the transformations to this to get our new graph. So A, again, there's nothing in front here, so it's just a 1. H is the number inside with the x, but change the sign. And K is the number at the end, keep the sign. Our vertex is at HK, so 2, -3. The vertex for a cubic is the middle of this bend right here. So our new middle bend spot is going to be at 2, -3. So 1, 2, 1, 2, 3. And we can see we're just going right 2 and down 3 for all of our points. So we'll go 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And then 1, 2, 1, 2, 3. And then here is going to be our new graph. Okay, we've got, I think, 3 more examples, and then we'll get you on your way so you can do some homework. All right, last one for us graphing. We're going to do a cube root function. So we'll find A, H, and K. And then we're going to find our vertex. But first, let's start with the parent function. Okay. So our parent function for f of x equals the cube root of x is the same as the parent function for the cubic one, except we switch x and y because they're inverses of each other. So when we do inverses, remember, if you have 2, 8, the inverse of that, we just switch the ordered pairs, and it'll be 8, 2. So for our cube root function, the parent function's x's are all the y's of the cubic function. So it'll be -8, -1, 0, 1, 8. And then the y's are all the x's from this one. So it's going to be -2, -1, 0, 1, 2. So let's go graph these ordered pairs. Let me switch to blue for the parent function. So we're going to go left 8, down 2, left 1, down 1, 0, 0, right 1, up 1, and then right 8, up 2. And here is our cube root function. Okay. Now let's find A, H, and K. Let's do green. So A, we still don't have anything there, so it's going to be a 1. H is this number, but change the sign. And K is this number, keep the sign. and our vertex is still at hk. So -1, -8. So we're going to go left 1, down 8. There's our new vertex. The vertex is that point right there. So now we can move all these points. Or we can just reproduce the pattern from the vertex. So this point from the original vertex is right 1, up 1. So this point on the new graph will be right 1, up 1 from its vertex. The same thing with this one. It's down 1, left 1. So it's going to be down 1, left 1 from the new vertex. Then this point, this one's kind of far out there, so maybe we should count. We'll go left 1, down 8. So left 1, 1, 2, 3, 4, 5, 6, 7, 8. Same thing here. Left 1, 1, 2, 3, 4, 5, 6, 7, 8. So here is our transformed cube root function. All right, cool. Now we're going to practice going the other direction. We're going to give you the graph, and then we're going to figure out the equation. All right. So here are some steps that we can follow. We're going to start by finding the vertex, because that will tell us h and k. Then we're going to figure out, was it flipped or not? That'll tell us a. Once we have h and k, we're going to say, all right, this is a cube root function, and then we're just going to plug a, h, and k into a cubic function. All right, so our vertex is this spot right here, right in the middle where it bends a whole bunch. So that looks like it's at -2, -1. So vertex is at -2, -1. Remember that our vertex is made of h, k. So this is telling us h, this is telling us k. We can also see that this is right side up. It looks like our parent function. It's not flipped over. If it were flipped over, it would look more like this, like a backwards S. This looks like a correct S. So we know that a is still going to be +1. So now we have h, k, and a. H equals -2, k equals -1, a equals 1. And we know this is a cube root function because of the shape of the graph. So now we're going to use this information and these three numbers to write our function. So f of x equals a cube root. Put the x on the inside. Let's talk about h really quick. When we look at the equation, it says +1, but our vertex is at -1. So just like when we take it out of the equation, we flip the sign. When we put it back into the equation, we need to flip the sign again. So even though our h is -2, we need to flip that to get it to go left 2. So we're going to put +2 in here. K always stays the same, -1. And then our coefficient of 1, we can write it, but it's not necessary. So 1. And this would be our equation. All right, let's do another one for practice. All right, this one, our vertex is the middle of this bend right here. So the middle looks right about there to me. That ordered pair is 1, 2, 1. So our vertex is at 2, 1. That's telling us h equals 2, k equals 1. This looks like the parent function, right? It's not flipped over. If it were flipped over, it would look like that. Okay. So this is the parent function. So because it's not flipped, a equals 1. And this is a cubic function, or an x cubed. So now that we have our a, h, and k, we've determined the type of function. Now we're going to write our equation. F of x equals 1 for the a, parentheses, put an x inside and a cubed on it. Remember, when we put h back in, we need to switch the sign, so -2. And then when we put k in, we don't switch the sign, so we'll keep it a +1. And this is our equation. Sorry, I probably shouldn't write through the cube like that. There we go. Not too bad. So if you guys have any questions about that, please ask me. I understand that this is kind of a lot, and this writing the equation from the graph is new to us. But if you follow these 4 steps, you should be okay. But as always, if you need help, please let me know. I would be happy to assist you. Have a great day.